Hello. Welcome back to another episode of Casual Math Wednesday, where every day is Wednesday if you're serious enough. Today we are going to look at the algebra exponents with the algebraic expressions. So we are just going to jump in, and I thought in this video I'm going to explain the rules as we go. Hopefully that would be better. You can let me know in the comments. Okay, so the first one that we look at, we can immediately see that the 4x and the 3x, they are the same term, and the 3x is a term on its own and the 3 is the constant. So first we go and let's rewrite it. Let's write x 4x squared plus 3x squared plus 3x plus 3. And then we can have a better picture. So 4x squared plus 3x squared. So because it's plus, nothing happens to the variable or the square. So it's only the coefficients that gets added. That is 7x squared plus 3x plus 3. And that would also be your final answer because there's nothing else that you can do. Our next equation, let's look here. Oh, they are trying to trick us here and here. So technically, this 8 and this 8 is the same term. So if we go and let's rewrite the rest, we are ignoring them at the moment. We're giving them the hand. Q R, and then we say plus 8. So we say QR. You always want to write your variables in alphabetical order, especially in this case, because you might miss that they are the same equation, and then you're like, okay, but there's nothing else I can do. But that might not be true. So if we rewrite it like this, you see that looks so much better on the eye. Your eye catches the same term quite quicker. So 7q squared, nothing happens to that. There's no other term to add, multiply, divide, or subtract from it. Plus the 7q square r, same story. The plus 8qr minus 8qr, that is basically 0. So then we just write the constant. And as you can see, there's nothing else that you can do. I see there's a little mistake there. That should be r, then the square there, my mistake. And that would be your final answer because there's nothing else that you can do. This one, they're trying to trick us here with a little bracket. That's not going to stop us. So we multiply that in 6b plus 3b squared plus 9b. We can see the 6b and the 9b is the same term. So we can rewrite it as 3b, and we add those two together to get the 15b. So in this equation, we can quickly spot the 5a and the 2a. So just to make it easier on the eyes, let's rewrite the whole thing. Let's say 5a squared plus 2a squared plus 5a plus 9a. See, I'm moving that 9a there. And remember the little a to the power of 3. Okay. Now we can go and add that together. So that would be 7a squared plus the 2a to the power of 3 plus 14a. We add those two together. And usually in this case, you can go and rewrite it as 3a to the power of 3 plus 7a to the power of 2 plus 14a, so that it is in chronological descending order in the power ofs. Our next question has a little power of, and we get to divide with an x. So what do? We don't crawl underneath our table and cry. We just go and split them. If you're not happy with the bracket, you go and split them, only if the base allows it. Okay. So first thing first, let's split them. So x to the power of 2 over x plus 6x over x. We split it. And as we've seen in the previous video, if we bring that one up, it will become a minus 1. And then we have the plus 6x 1 minus 1. We all know that anything to the power of 0 is always 1. So you can have a ridiculous amount. Ridiculous. To the power of 0 is 1. It's always 1. So if we go and check, we can say x, the 2 minus 1, that's the 1, plus 6 times 1, that will give you the answer of x plus 6. Let's challenge ourselves a little. Let's look at this little fella here. It looks intimidating, but it is quite easily. So with this 3, we take it into there and there. Take this 5 in to there and there. So here we're using BOTMAS. So it is the brackets of divide, multiply, add, supply. More details of that in the next video that's coming up. Super excited for that. So we can go and say 64a to the power of 3 times AB plus 32 A5 times B3. Did you notice that this term and this term is the same? So we can go ahead and say that this is 16a squared B. And now if further we multiply that, so it would be 64a 3 plus 1 for the one there, the little one there, plus b plus 32a to the power of 5 b 3 divided by 16a squared b. And the same as the previous problem that we did, we go and split the bases. So I'm doing 2 steps here in one. So we say 64a to the power of 4 for the 3 and the 1 there. B over 16a squared b plus 32a to the power of 5b3 over 16a squared b. And now we can go and say 64 divided by 16. That would be 4. A 4 minus 2. B 1 minus 1. Plus 32 divided by 16. That is 2. A 5 minus 2. B 3 minus 1. And so we go and say 4a squared, b 1 minus 1, again that would be b 0, that would give you 1. So we're not going to include it. So 2a 5 minus 3, it is 2a to the power of 3, b to the power of 2. And that is your final answer. And just before the end of this video, I just quickly want to make sure about something with you guys. And that is the next. If I write, as we know, I said 4a to the power of, so you flip it in and flip it in, so it'd be 4 and a 4. But if I say a plus b square is a square plus b square, that is not true. When there's an add or a plus or a minus, two terms in any way, you cannot flip them in, only if it is one term. So, and why is this the case? Like everybody said, just take it in. Well, let me show you. So, a plus b square. That means it is the term a plus b times the term a plus b. And here I like to call it the parrot clause, because it looks like the clause of a parrot as it sits on a stick. So you times a times a times b. You take the b times a, b times b. So if you look closely, it kind of looks like a parrot. So all it needs is like the little legs here and a stick there. And there you have your parrot's claw. That's why I call it the parrot. So with all my scratching and the foot that's in the way now, the a times the a, so that'll be a times a plus a times b plus b times a plus b times b. I hope you followed with the claw there, so I can show again. So the a and the a is the a and the a and the b is the a and the b and the a, the b and the a, the b and the b, the b and the b. And there you created another parrot claw. A times a, so that would be the 1 plus the 1 to the power of there. So it'd be a square plus AB plus BA plus B square. Funny, that spells ABBA. Okay, A square. These are the same terms, so let's train the eye, write them in alphabetical order. There you can easily spot that it's the same term, and it doesn't say ABBA anymore, it says ABAB. So we have the A square plus 2AB plus B square. So that is why you cannot take that in. It is not equals to that. Do not let me catch you ever do that in a question paper or exam, or even just telling someone. That is unacceptable. I don't know how it will come up in a conversation. But with that, thank you so much and a happy Wednesday. This is Tiger. I hope you learned something today. And peace. Don't be fooled by math. Bye.